Today's lesson we're going to talk specifically about the sine and the cosine functions. These are called trig functions. They are two of the 6 that we'll study in this unit: sine, cosine, tangent, secant, cosecant, and cotangent. But the main ones and the ones that all basically evolve from are the sine and cosine functions. The objective then is to use the definition of them to find the value of those functions and to sketch the graphs of their functions. So first of all, a definition of the sine and cosine function. So first of all, it says suppose P of xy is a point on a circle. So if this is a xy coordinate system and we have a circle, and we talk about a point that's on that circle. Let's say this point right there. Okay, and again we could talk about an angle. Remember, the angle starts at this terminal ray, and if we rotate it, we'd be talking about this angle theta, which looks to be about 75, 80 degrees and so on. Then we would define the sine of theta, denoted sine theta, by y over r. Now where that comes from is if I drop this straight down and I form a right triangle, this is my y coordinate, this is my x, and this would be the r, which would be the radius of that circle. So I basically have a right triangle that looks like this. This is the y, this is the x, and this is the r. Alright, so if this point right here, let's say, had the coordinates of 3, 4, then that's a 3, 4, and then using Pythagorean theorem, or remembering those Pythagorean triples from John Baylor Prep, this would be a 3, 4, 5 right triangle. And the sine of this angle would be defined as 4/5, the y over the r. That's the ratio, and again, a lot of you have learned SOHCAHTOA. It's the ratio of the, as this being your angle, the opposite over the hypotenuse. And then we would define the cosine of theta as x over r. Adjacent, this would be the adjacent side then, over the hypotenuse. In this case, of this angle, it would be 3 over 5. So looking at some examples of using the sine and cosine definition. So the first problem says if a terminal ray of an angle in standard position passes through the point negative 3, 2. So again, if I have a coordinate system and I have a circle on there, and if I have an angle, this angle is actually in the second quadrant, and this point would be negative 3, 2. I'm going left 3 and I'm going up 2. The angle we're talking about is this obtuse angle right here. Okay, but we can solve this by dropping this straight down, forming a right triangle. That right triangle would look like this. This x is negative 3, my y is 2, and then using Pythagorean theorem, x squared or a squared, which would be 9, plus b squared would be 4, then I would take the square root of that. So that means my radius, or my hypotenuse, would be the square root of 13. So then, sine of theta from our definition is y over r. In this case, that'd be 2 over root 13. The cosine of theta would would then be x over r, which would be negative 3 over root 13. Next example says if theta is a fourth quadrant angle and sine of theta is negative 5/13. So in this case, it tells me that my angle's in the fourth quadrant. It's down here someplace. If I make a triangle by going either vertically to the x-axis, sine is y, so my y is negative 5. That would be this length. My r is 13, that's the hypotenuse, or the radius, sorry, of that circle. So that triangle looks like this. This is 5, this is 13. Using Pythagorean theorem, or again, those Pythagorean triples, 5 what 13, 5 what 13, 12. So then the cosine of theta, and if it's in the fourth quadrant, I know this is positive. The cosine of theta would be a positive 12 over 13. X over r. Alright, so how does this apply as far as finding the value of the sine and cosine using the unit circle? So if I'm asked to find the sine of 90 degrees, if I draw a diagram, that has the unit circle, so this is a circle with a radius of 1, and the 90-degree angle, again if I rotate counterclockwise, the 90-degree angle would be this angle. Where that angle crosses this unit circle, it would be at the point 0, 1. Alright? And then remember the radius is 1. So sine from our definition before is y over r, which would be 1 over 1. And as we talked about unit circle, it's just basically the y coordinate. So the sine of 90 would be 1. All right, and you can check that on your calculators. Just type in sine of 90 if you're in degree mode. It should give you 1. The next one here, cosine of 270. 270, I would rotate this direction. This would be 270. And this point would have the coordinates 0, negative 1. Now I'm looking for the cosine of that, which is defined as x over r, but on a unit circle, it's just the x, which would be 0. Cosine of 270 would be 0. And I apologize again for my stylus here. So for your assignment today, as your code word by your name, put get a new stylus. Alright, sine of pi. So this is in radians. Pi radians, remember, is 180 degrees. So in this unit circle, I would rotate this direction. That's 180 right there. It should be this one. Where does that cross this circle at? That point would have the coordinates negative 1, 0. Left 1 and up 0. Sine is then the y coordinate, which would be 0. I'm going to stop this video now and then I'll restart another one.